Hey guys, so we are going to start today with new material. I know it's Wednesday, it's in the middle of the week, but we're gonna, actually it's Thursday for you guys. It's Wednesday today, it's Thursday for y'all, but we're gonna go ahead and kind of move on with new stuff. And today we're gonna talk about rocks, and we're gonna talk about the rock cycle, okay? So we're gonna talk about different types of rocks, then we're gonna talk about how rocks change from one form to another form. So we're going to focus on the three primary categories or types of rocks. We're going to talk about sedimentary rock, metamorphic rock, and igneous rock. Okay, but before we do that, we're going to kind of take a step back before we really get into detail about this picture and talk about the rock cycle. We're going to talk a little bit first about minerals. Okay, so we're going to start here with minerals and rocks. You're writing all of these definitions down. It's not very many, okay, but you're going to write all these definitions into your notes, and when we get back, I'll do a notebook check. Okay, so minerals. A mineral is a naturally occurring inorganic. Okay, inorganic means it doesn't have carbon. Okay, it doesn't have carbon in it, and these are things that are non-living. Inorganic means non-living. So, mineral is a naturally occurring inorganic solid that has a definite crystalline structure, and we're going to look at pictures in just a second, and I think this crystalline structure is going to kind of make more sense, but pretty much it looks like a crystal. It looks like a jewel, okay? So if we're kind of, if most people are being honest, they're going to say that a mineral is prettier than a rock, okay, a lot of the time. So they've got a definite structure and chemical compound. So they have a definite chemical compound, and that is telling us that they're pure. Okay, they're pure. They're not made up of a mixture of different things. That mineral is going to be the same chemical compound all the way through it. Okay, that's what a mineral is. A rock, on the other hand, the difference between a mineral and a rock is a naturally occurring solid that is a mixture. Is a mixture of one or more minerals, okay? So it's not just one mineral. It isn't pure. It is a mixture of minerals, and it may also include organic matter, okay? So in that mixture of different types of minerals, there might also be compressed organic matter like soil or a lot of, dead leaves and grass and things like that. So that's what it's talking about with organic. So minerals are pure, they're crystal, they're all inorganic, and then rocks are a mixture of minerals. So if we look here at some pictures, okay, you got a rock on the left, and that's actually a piece of granite, okay? So it's a granite, it's a rock. Granite is actually a type of igneous rock. On the right, we have a mineral. I can't remember what mineral that is, but it is a mineral. All right, and so that's what it's kind of talking about with that definite crystalline structure. It's really, really clear. You can tell that it's pure all the way through, so that's a mineral. When we're talking about minerals, we have 6 different properties that identify minerals. Density, the hardness of the mineral, the color, the streak, the luster. So luster right here, another way we can kind of talk about that is how shiny it is. Okay, how shiny it is. Fracture and cleavage just talks about if you take that mineral, some minerals, when you scrape it against each other, little pieces of it will fracture off, and then also the shape. So that's kind of how minerals are sort of differentiated as, between different types of minerals. Let's see. Okay, now let's get to the rocks. So when we're talking about rocks, there's going to be 3 main types of rocks. You have to know these rocks, okay? You have to know, especially what we're going to talk about next when we talk about the rock cycle, you're going to have to know how these rocks change from one form to another. So sedimentary rocks, they form when the weight from above pressed down on the layers of minerals or sediment. So, and these definitions are going to make more sense when we're looking at the pictures, okay? I promise. When we look at the pictures of the rock cycle. So it is when, another thing that you probably need a definition of is sediment. And those are things like dirt, soil, sand. They're all small particles. All right, so that's what sediment is. So all of that sediment, those small particles, they get pressed and compressed and compact together, and they form sedimentary rock. Remember, the other thing that we have to think about with this rock cycle, we're talking about types of rocks. This happens very, very, very slowly. It's not something that's going to happen really quickly, okay? Not something that happens really fast, okay? So we've got sedimentary rocks. Sedimentary rocks are going to be able to form metamorphic rock. Metamorphic. And so metamorphic forms when high temperatures and high pressure change the texture mineral contents of rock. So you have a sedimentary rock, heat and pressure build up, and that changes into a metamorphic rock, okay? And then finally, so what's happening is that metamorphic rock can continue to heat up and heat up and heat up, and finally, if it heats up enough, it is going to actually melt. We don't think about rock melting, but it does, okay? And once that rock melts, it forms something called magma. Well, eventually that magma flows to the surface where it cools off, and it forms igneous rocks. So igneous rocks, oh, there's a typo in my PowerPoint. It should say form from pooling magma or lava. All right, so they form from pooling, and it actually should, look, there's so many typos. It shouldn't be pooling, it should be cooling. I'll go try to change that in y'all's actual PowerPoint that you're copying for notes. So igneous rocks, they form from cooling magma or lava, okay? They form from cooling magma or lava. So we've kind of done a little overview. Here's some examples of sedimentary rock. You are not, in my class, going to have to identify. I'm not going to give you a rock and ask you what type it is, okay? I'm not going to do that. So here's some sedimentary rocks. Metamorphic rock. This rock kind of looks like it's spelled gneiss, but it's actually pronounced nice. All right, so that's some nice. Slate, quartz, honestly can't see the bottom, schist, marble, and phyllite. Not really sure. But marble, we use those for countertop. I don't have marble countertops, but people can have marble countertops. Igneous rock, these are the ones that are kind of formed from magma that cools. If you remember talking about plate tectonics and the ocean floor, most of the rock under the ocean is called basalt. Okay, so that is an igneous rock. Trying to think of some more that you might. Pumice. Try to make those little buttons go away. Down here at the bottom right. Oh, crap. Well, pumice can kind of be used to exfoliate skin and things like that. So those are igneous rocks. Okay, so the rock cycle, this is kind of what I've been hinting at. This is where most of your questions will kind of come from. This is probably the most important part. These are a series of processes. Man, this is the worst PowerPoint I've ever made. Processes that continually change one rock type to another, okay? The series of processes that continually change one rock type to another. Okay, this is a cycle. Okay, this is a cycle. So a cycle doesn't truly have a starting point. You can start anywhere in this rock cycle, okay? So, and you have to be careful because each image of the rock cycle might look a little bit different. Here in this image, it starts with igneous rock up at the top. In this one, it's got sediments and sedimentary rock at the top, okay? What matters is what's happening to the arrows, okay? What's happening where each of the arrows are. What do you start with and what do you finish with, okay? So there isn't a true starting point, but the easiest place for me to start and think about is right here with sediment. Like I said, you can kind of start anywhere, But the most natural starting point right here is for me is sediment. And that's things like soil, sand, dirt, stuff like that. So that sediment is going to get compact and cemented together. It's going to get pressed together. All that dirt, all that soil is going to get pressed, compacted together, and eventually form sedimentary rock. Okay, so this is sort of our first type of rock. It's going to form that sedimentary rock. Now, here's the other thing. The rock cycle doesn't just go one direction, okay? There are multiple different steps and multiple different directions it can go. If that sedimentary rock, if it undergoes weathering and erosion by wind and rain and other weather events, then it doesn't go to metamorphic rock. It's going to go back to sediments, okay? So weathering and erosion of any of these rocks, I don't care if you're talking about sedimentary rock, metamorphic rock, or igneous rock. If they get weathered and eroded, they're going to form sediments, okay? All of it is going back to forming sediments, all right? But let's stick to what we were just talking about. So we're going to start here with sediments. They are going to get pressed and compact together, and they're going to form sedimentary rocks, okay? Now, those sedimentary rocks, over time, are going to get pressed deeper and deeper into the earth, okay? Because when we talked about relative age dating, older rocks, they kind of get pushed to the bottom and new rock gets put on top, okay? So as they get lower and lower and deeper into the earth, we know as you start digging deeper and deeper into the earth, and you get really, really deep, I'm not talking about digging with a shovel, but you start getting 5, 6, 7, 800 feet underground, the temperature starts to rise because you're getting closer to that core of the earth, okay? So as that temperature rises, the heat and the pressure increase, and that sedimentary rock is going to be changed to metamorphic rock, okay? So we have sediments, and then the sediments can be turned into sedimentary rock. The sedimentary rock can be turned into metamorphic rock. And then there's a couple different things that can happen with the metamorphic rock. Okay, so that metamorphic rock, as it is heated up, okay, if it continues to heat, it's eventually going to melt into magma. So if it keeps getting deeper and deeper and deeper into that Earth's mantle, then it's not going to be a rock anymore. It's going to melt to the point where it's liquid. What we call liquid molten rock is magma. Okay, so if it continues to melt, then we're going to have magma. As things get hotter, magma is really, really hot. As things get hotter, they want to float to the surface, okay? They expand out. They're going to want to float. So that magma starts to rise, okay? Maybe it's going to flow out of a volcano. All right, so that magma is going to rise. As it rises, it cools. If you have magma and it cools, as it cools, it is going to solidify, okay? So another word you could see here is cooling and solidification, okay? That means it solidifies. It turns to a solid. And once that magma solidifies, then you have igneous rock, okay? Igneous rock, all of the rock around volcanoes and things like that, those are all igneous rock. So we've gone from magma, now we're to igneous rock. That igneous rock is going to weather and erode and get broken down into sediments. That sediment is going to get compacted and cemented back into sedimentary rock, and we're just going to go through the cycle again. Okay, over the course of hundreds and hundreds of millions of years, it's just like a continuous rock cycle. So we can go the rock cycle this way, but there's also areas of the rock cycles where we can kind of go backwards. And we talked about that with the weathering and erosion. I don't care if you're starting with sedimentary rock, metamorphic rock, or igneous rock. It doesn't matter. If you weather and erode, you're going to turn into sediments, okay? It doesn't matter if you are talking about igneous rock or sedimentary rock, if you apply heat and pressure, it's going to make metamorphic rock every single time. The only way that you get magma, is if it melts, okay? So there isn't a way. I mean, you could draw an arrow where you could say that if you melted a sedimentary rock, it became magma, but that's just not very likely to happen. But this is the rock cycle, okay? You have this video, you have these notes. I'm going to post a couple other YouTube videos that might kind of do a better job of going through the rock cycle. So for today's assignment, you're going to have reading material on the rock cycle, and you're going to have to go through and answer the questions in the passage, okay? So you're going to use Kami to type in the answers to the questions. They're all there in the reading material, but that's going to be your assignment today. And then we'll have another assignment on Friday. All right? Email me if you have any questions. Bye, guys.